Good morning. Now, today I want us to continue with our lesson from chapter 7. We have been advised that we have to complete the syllabus by the end of this term. We are on chapter 7, heat transfer. We defined heat. We looked at the difference between heat and temperature. We also looked at a mode of heat transfer. We looked at conduction. We say that the process by which heat flows through solid substance. We also looked at convection, which is that the process by which heat flows through liquid and gases. Now today I want us to look at thermal radiation. And we say that thermal radiation is the process by which heat is transferred through vacuum. Another point we have to note is that the heat from the sun reaches the Earth's surface through radiation. It reaches the Earth's surface through radiation. Now, point number 3, we say that all bodies absorbs and emits radiation. Now, if you are near a source of heat, you will feel that heat. Now, that means your body has absorbed the heat. Now, we also say that a body emitting thermal radiation can also emit visible light when it is hot enough. For example, we have electric bulb. Now, inside the electric bulb, we have a filament, or just a small coiled wire. Now, when electricity passes through it, it heats up. The wire is heated up, and then it glows. Now, when it glows, it produces the light. Now, I'm just trying to explain that point. Now, I want us now to look at emission and absorption of radiation. And we'll start with number 1. We want to compare the rate of emission of radiation from different sources. And then number 2, we look at to compare absorption of radiant heat by different sources. Now let's first start with this one. Compare the rate of emission of radiation from different sources. Now, here is a point that I want you to note, that a good absorber of radiant heat is also a good emitter of radiant heat, while a poor absorber of radiant heat is also a poor emitter of radiant heat. Now, this point means that a body that absorbs heat very fast, it will also emit that heat at a higher rate. Now, a good absorber, it will emit, is also a good emitter. Now, a body that will absorb heat at a lower rate, it will also emit that same heat at a lower rate. Therefore, a bad absorber, it is also a bad emitter of heat. Now, consider the setup below. Now, we have this setup. On this side, we have boiling tube A, which is black. As you can see here, it is labeled black. You have air inside it, and then it is connected. Now, this is a YouTube. It connects to the other boiling tube B, which is also black. It has air inside, and then inside this limb, we have colored water. Now, in the middle, you see here we have distance x and distance y. Distance x and distance y are equal. Now, here in the middle, we have hot water in a basin, but on this side, it is painted black. On this side, the surface is polished. Polished, it means it has either a shining surface or it is painted white. I will use that term polished. And when you see that term polished, it means it has a shiny surface or it is painted white. Now, I want us to look at the observation that we make from this setup. It is observed that water in limb A rises up while that in limb B falls. Now, water in this limb will go up, and this limb it will move down. Now, I want to explain why that observation was made. explanation say that this is because volume tube B received more heat than volume tube A, warming the air inside it more. The air expands now when the air expands, it increases the air pressure and therefore pushes down the water in the B. As a result, the level in limb A rises up. Now, you see at this side where the surface is painted black, it means it will emit heat more easily or at a higher rate than this other side, and therefore meaning on this side the air will be more hot than on this side. Therefore, when it reaches this boiling tube B, the air inside will expand because of the heat. Now, when it expands, it will create more air pressure. Now, that air pressure is what will come and push this colored water in limb B. Therefore, the water in limb B will fall and limb A will rise because this side is painted black. Now, say that this experiment suggests that black surfaces are better heat emitter than polished or shiny surface. Hope you have understood there. Now, I want us to look at the graph. Now, we want to relate this observation graphically. A graph showing the rate of emission through different surfaces. Now, we have this graph. Here we have temperature. We are plotting it against time in minutes. Now, the graph shows that a shiny polished surface loses heat less rapidly than a black surface. Now, in this graph, as you can see, the temperature is high, but after some time, you'll find that the temperature in black surface will fall more rapidly than in shiny surface. You see, for example, we want to look at temperature at this point. You see the temperature here, it is lower than a temperature in shining surface. Now that's how we represent that observation in a graph. Conclusion, say from the graph above, black surfaces are better emitter of heat than shiny surface. Now hope you have understood that. If you have any question, let me know so that I can clarify it.